Hello everyone, good evening. I am Muskan. Okay, I'm associate data scientist. So welcome to this live session on optimizing aluminum procurement through price forecasting. We are diving now into how data science can literally save your lakhs, even crores in raw material procurement. Okay, so this is our project title, which is optimizing aluminum procurement through price forecasting. So first is the business problem. Okay, how can we deal with the problem? So the business problem is the company faces challenges in efficiently procuring aluminum, a critical raw material for the steel and manufacturing industries. So currently procurement is carried out on an ad hoc basis without considering the price fluctuation. So what this company is doing, so this company is directly buying the material without without checking the price of that material. Okay, this react approach often lead to the higher procurement costs, directly affecting the company's operational efficiency. So because of that only, it is directly affecting the company's operational efficiency and portability. So implementing a more strategic and data driven approach to the aluminum procurement, this can be help in mitigating these challenges and optimizing cost. So what this company is doing, it is directly buying the material without checking the price or the stock price of this aluminum price. So this is the problem this company is facing. So because of that only, we have gone through some objective and the constraint for this problem. Okay, so we get the objective, like minimizing, we can minimize the procurement cost as objective. We are writing this, and the constraint, what can we write? We can minimize risks and the market volatility. So we have three success criteria. Okay, one is the business success criteria, another one is ML success criteria, and next is the economic success criteria. So the business success criteria we can write as reduce procurement cost by at least 25%. Okay, we have to reduce the procurement cost at least by 25%, and the ML success criteria for that is we need to achieve an accuracy of at least 90% in predicting price trends. Okay, the economic success criteria we can write for this as cost effective development and maintenance within the school's budgets. Okay, so the next. Okay, next is the model architecture. So how can we draw the architecture for it? So first we will get the data from the different sources. We are having different sources for the data collection. We can say the primary and the secondary source. The primary source is nothing but that source where we need to generate the data. Okay, we need to search on the data. We need to data is nothing but the data where which is already available data, and we can get it very easily. Okay, so we are having two types of data. So here we are getting the data from the client side. Okay, after we are getting the data, we will go for under whatever after getting that data, we go for the business and the data understanding. Okay, first we understand what is the business behind that data, then we go for the understanding of that data. Okay, so after understanding what is the problem with that, then we'll go for the data collection. We store that data, whatever we got the data from different resources, we store it. Where we can store it? We can store it into the different databases. So there we are having two type of the databases. We can say that if we are having the structured data, where we need to store the data. If you are having the unstructured data, then where we need to store the data. So we are, as you all know, we are having the different databases like MySQL, NoSQL, okay, MongoDB. So here we are storing our data into the Amazon S3 bucket. Okay, here we can store our data. So now, as of now, we are storing data into Amazon S3 bucket. Okay, after storing the data, we go for the pre-processing, data pre-processing. So what we do in it? So here, whatever the raw data we will get, we prepare it. Okay, by applying the different methods, here we prepare the data. Like we can check the missing value, we check the duplicate, we check the outlier. Okay, After that, we prepare the data in data pre-processing step. After preparing the data, we go for the model building. Okay. In model building, what are the steps we do? We will select the data. Sorry, we will select the model. Okay. So here in this project, we have selected some model like AR model, MA model, ARIMA model, ARMA model, and SARIMA model. After selecting the model, we need to train that model. Okay. Before that, we need to split our data into train, test, and validation. So with the train and validation data, we train the model. After training the model, we test that model with the test data. Okay, then we check the accuracy of it. If we are not getting proper accuracy, either we need to rebuild the model, retrain the model, or else we can do the hyperparameter tuning to it. Okay, after doing the hyperparameter tuning, we will get the good accuracy. Okay, after getting the good accuracy, we'll go for the model evaluation. Here we evaluate our model. Okay, after evaluating the model, we'll directly go for the model deployment. So in model deployment, we can do the model deployment by using, okay, by using Streamlit or the Flask. Okay, so we did by using the Flask. Okay, after doing the deployment, we go for the monitoring and the maintenance. In monitoring and maintenance, we monitor the data. Okay, after doing the monitoring and maintenance, it will be the end user. It will go for the end user. This is nothing but your architecture of your project, the aluminum price forecasting. Okay, next. Okay, then we'll go for the model building. Okay, so as I told you, we are using the different models. Okay, we are trying out ARIMA, SARIMA, LSTM models. Okay, so in this ARIMA model we are using, what is ARIMA? Auto regressive integrated moving average. Okay, so what is the purpose of it? So as of now, as we know that the aluminum price forecasting, it will be whatever the data we have, that is nothing but our time series data. Okay, so that because of that only we are using ARIMA model. What is mean by that? ARIMA is nothing but auto-regressive integrated moving average. Okay, next. So how we implemented it? I implemented it. Okay, data stationarity we check, which is nothing but the ADF test. Next, we done the differencing to the actual stationarity. Next, we also drawn the visualization. Plot the fitted ARIMA model versus the actual data. Okay, next we also use the SARIMA. What does it mean by SARIMA? SARIMA is nothing but seasonal, auto-regressive, integrated moving average. Okay, what is the purpose of it? Purpose is nothing but to handle the seasonality. We are using SARIMA model. And how we did the implementation for it? We first identification of the seasonality, that is nothing but the seasonal decomposition. Next, seasonal differencing to remove the seasonal pattern. We also drawn the visualization for it also, which is nothing but plot of the fitted SARIMA model versus the actual data. Next, LSTM. What is mean by it? LSTM is nothing but long short-term memory. Purpose for that is sequence prediction. Then we also did the implementation for that, which is nothing but the data pre-processing. What are the data pre-processing steps we applied here? We applied normalization, train, test, split. Next, the model architecture design also we did here, number of the layer, neurons, activation function, etc. Next, the model training we did by using the hyperparameter tuning, which is nothing but the we check learning rate, batch size, epochs. And the visualization also we did. We dot here also we visualize the plot of the fitted LSTM model versus the actual data whatever we had. Okay. Next, the model accuracy. Okay. So the model accuracy. So forecasting model, a comparative analysis. So we check the MAP value, mean absolute percentile error. Okay, we check it in ARIMA, SARIMA, LSTM, a traditional time series forecasting method, which is nothing but ARIMA. An extension of ARIMA, seasonal data pattern is nothing but the SARIMA. A recurrent neural network captures long-term dependency, which is nothing but LSTM. So we got different MAP value here. We got for ARIMA, we got MAP value as 13.05. For SARIMA, we got 9.21, and for LSTM, we got 4.59. So LSTM model demonstrated the highest accuracy in predicting aluminum price trends. Its ability to capture long-term dependency makes it ideal for this task. Next, this is nothing but our deployment part. Okay. After running the Flask file, I got this deployment part. Okay. So this is my browse history. Okay, in that I got this is the AiSPRY logo, everything I had given in the code. So here I need to put the input. So I wanted to forecast for how many month or how many years. So start date, I need to insert here the start date, whatever from which date I wanted to forecast, and the end date is nothing but the time period from first date to last date. Okay, then I need to enter here the confidence interval. So after that I'll get the result, which is nothing but it see here I have taken input start date as the I started in 2025 only. I have taken 5th month first date, 10th month 31st, means I have forecasted for 5 months with the confidence interval 0.95. Okay, so I got the prediction with the date, what is the predicted value for that, what is the lower bound and what is the upper bound for that. Okay, then I also got the graph for it, whether it is giving the proper result or not. The blue, dark blue line we can see, you can see that is nothing but your forecasted value, and the green dotted line is nothing but your upper bound, and the red dotted line is nothing but your lower bound. Okay, so before checking the challenges, we'll run that code. Okay, first I'll launch this. Okay, 3D space, I'm giving my path for it. Okay, this is my path. I'm taking that where I'm having my pickle file, .py file and template stats and all. Okay, here you need to go, you need to paste it here. So I'm taking the path, whatever I have. Okay, now I'm checking the directory. Yes, I'm having the file, whatever the files it have in that same directory, I'm checking that. So to run the Flask, we are having the code like Python space your py file. Okay, my py file name is app02. Okay, so this is my py file. Okay, okay, just a minute. Python space. Yes, I got it. Okay, so this is my first page after running that. So here I need to put an input. So I'm starting from, I'll take 1 month of the forecasting. Okay, I'll start from the month. I'll select the February month. Okay, whatever I did, fib me. Okay, I'll take from Friday. Then I'll take the November. Randomly, I'm taking the value. Okay. The complete month I'll take. Okay. The confidence level I'm taking, keeping as 95. Then generate forecast. Yeah. As you can see here, my start date is, I have taken 5th month. Okay. Second 2/5/2025 to 30/11/2005 with the confidence level 0.9. Okay. Can you able to see here? We are having the date, predicted value with the lower bound value with the upper bound value. So we can check the predicted value. So in the next month, what will be the price for the aluminum material? So at the time I can buy it. So because of that only, I have tested for 1 month. You guys can test for 2 months, 3 months, whatever months you wanted to check, you guys can check it. Okay. So this is the forecasting values for our data. Okay, and this is the plot, aluminum price forecasting plot. So it is coming properly. So as you can say, the date also, whenever you will click, it will change the date with the price. See the price also, you can able to see. Red is nothing but your lower bound, green is your upper bound, and blue is nothing but your forecasted value. Okay, this the x-axis is nothing but your month with the year, which is nothing but the date and the price. Okay, so this is nothing but that. Okay, let's go back to the PPT. Okay. So next we have faced some challenges also, which is nothing but the market volatility. Okay, we can say that aluminum price are highly influenced by the global market condition, as we all know. Geopolitical event and economic factors making accurate prediction. This was making it difficult. Okay, so we are also faced some challenges with the data availability. So we were having limited access to detailed data, high quality historical data, or the extreme factors like supply chain disruptions can impact model performance. Okay, so next we also face some problem with the external influences. So price can be affected by the unpredicted variables such as currency fluctuations, so the energy prices and changes in the government policies or the tariffs. So the model complexity, this is also one of the challenge we face. So developing a model that capture the right balance between historical data, extreme variables, and market behavior is complex. So the seasonality and the trends, identifying and accurately forecasting seasonal pattern or the long-term trends in the aluminum market can be challenging. Noise and the outlier, the presence of the noise and the sudden outliers like sudden price like or drops can reduce the accuracy of the forecast horizon. Short-term forecast may be more accurate than long-term ones, as prediction over long periods are more prone to error. Okay, these are some challenges we faced while we were doing that project. Then what we okay, so the challenging real-time project that push you to your limit. Okay, so what we are offering to you, see, you can take the 360 digit MG website. From there, you will get the mind map for it. Okay, this is we can say the short note, kind of short note. So if you will go with the mind map of it, every day if you will go through it, it will be very easy to understand it. Okay, you can able to read everything, whatever the concepts are there. Okay, so you can able to understand by using the mind map. We also provide you the architecture. Okay, in that website we are having option. Okay, we can create the architecture low level or high level. With the advanced level with be for the beginner, for the intermediate. Okay, we are having for the beginners also, you guys can also draw the architecture by using the 360 digit website. Okay, so next you can also find your perfect career fit for it. Okay, you can get it, and you also get the digital what we can say, the mind maps, the data, the projects, so you can understand it by using that website. Learning of all phases of the project methodology, you will get it. Learning about different tools used in the industries like Python, Power BI, cloud platforms, etc. Next, work on the research paper that are published in the international journal. Yes, we provide that. We publish the international journals. Okay, in that we also write top 3 students whoever do the best project. Okay, for them we will take their name and we will publish in the international journal. This is also the good point for it. Then access to the various free tools to enhance your learning. Yes, thank you so much, guys.